In this video, we are going to learn about problem solving. Now, in the context of programming, problem solving does not only mean to solve the problem mathematically, but after solving the problem mathematically, you have to observe all the steps scrupulously that you have followed and then write down all the steps as clearly as possible so that you can write the program also. Now, in the context of programming, problem solving means writing down all the steps carefully to solve the problem so that you can easily convert it to a computer program. Now, in order to do that, you have to follow a very fundamental approach. The first thing is, whenever you will learn some kind of programming language, you will have a tendency that, all right after getting a problem, if it is very easy, you directly want to jump on writing the code. Now, never do that, at least at the beginning level. What you should do is this. First, you have to write down the algorithm for the program. So what is the algorithm? Algorithm means the step-by-step instruction. So use the simple English or any language of your preference, your mother language, whatever it is, to describe each step of the mathematical solution. And after describing the problem in clear English or any human language, then you have to convert it to something called pseudocode. Now, what is a pseudocode? After understanding all the control structure and all the building blocks of problems, then you won't have much trouble in understanding what is pseudocode. So pseudocode is basically, you can say, this is a mathematical language. It is something between the English or some human understandable language and the computer program. It is something between that. You can use all the notations, all the operators, all the programming building blocks that you have learned in the previous videos to convert an algorithm to its equivalent pseudocode. Here in this slide, you can see some examples. For example, like in normal English, if you say like this, add num1 and num2 and store the sum in a variable called result. If this is the normal English, and if you convert it to pseudocode, it looks simply like this. Result equals num1 and num2. That is, add num1 and num2 and then assign or store the sum in the variable called result. That's it. Now the next one, that if the value of x is greater than 20, then print OK. Now you all know what is if. There is some control structure called if. There is a logical operator called greater than. So just convert it to those notations, like if, then x is greater than 20, then print OK. So this is an equivalent pseudocode for this English algorithm. The same for this one. You all know the loop can be demonstrated using this while keyword. And so if I say in English that loop until the value of x is less, then you can write the equivalent pseudocode just like this. So now let us jump into check how to solve a problem. Now, in order to solve the problem, as I have told, never jump directly to write the code. First, break down the problem into as small as possible. So for example, and a simple example can clarify the concept. The first one, let's say the example is write down the pseudocode to print all the even numbers between 5 and 100. How can you solve the problem? So first, I have divided the problem into multiple different steps. That is step 1, step 2, and step 3. Now in step 1, what I have done, I wrote in clear English that iterate each number from 5 to 100 one after another. And after breaking it down to step 1, write the code for step 1 like this. Now once you are done with this step 1, then move forward to write the code for step 2. And so what is the step 2? Now for each number what you are iterating over here, you have to write down that check if it is even or not. So you have to employ an if statement over here. So basically what I am doing, I am dividing the problem into multiple steps, clearly writing the instruction in normal English, and then converting it to pseudocode like this. So this is my step 2. And then finally in step 3, what I am doing, if it is even, then print. So I'm just writing down this print statement. And that's how you have to approach a programming problem. Whenever you will, so the basic mantra is, whenever you will get a problem, break down the algorithmic steps, write it down in English, and break it down as detailed as possible. So far you are not comfortable in writing the equivalent pseudo code for that. For example, let's say in this step 2, I have mentioned that, okay, for each number check if it is even or not, and then wrote the code like this: if I want 2 equals 0, like this. Now at the beginner's level, you may find it difficult to convert this entire statement into pseudocode. So instead, what you can do is, you can just break down this statement once again. For example, instead of solving like this, you can do again break down into, let's say, step 2a. Instead of writing if it is even or not, let's say write an if block of code, and then step 2b, what you can write inside the if condition, if it is even or not, check the remainder is divisible by 2 or not, something like this. So the thing is, so far you are not comfortable to convert the steps into the equivalent pseudo code. Just divide it as much as possible, go to the lowest granular level as possible, and when you are comfortable to convert these English steps to program, then it is okay. So instead of getting the problem and directly jumping into the code, write the simple English statement and convert them to equivalent code. Each step you should convert them to equivalent code. And if continue the breaking down process, as long as you are not comfortable to convert it to equivalent pseudocode.